The SQL Server security, actually, we started last class. It was summarized that, let's say, small perspectives. We started with the themes that we have to go beyond, which are four themes that through which we can implement a secure framework, secure environment. Here, technical about the security measures we have to settle in order to achieve the secure environment, secure framework. On top of which the DBMS engine has to run, or the project in question managing the DBMS content or the databases would be settled. The themes, actually, they are the first preview via which we saw four themes. Actually, uh, they are not going to isolate the system, but they are going to settle, actually, an environment where, let's say, users, they are going to be at least recognized. So we are going to deprive the intruders from having a chance to intrude or access the environment somehow. Somehow, remember why I'm not confirming 100%, and none of you can confirm that. Why? No 100% secure system. We are just elevating the security level by design, by default, communication or the deployment. Those are approaches, those are themes via which we technically set up a secure environment, on top of which the DBMS or the project tackle and your database actually will be running. Uh, remember that, actually, the elevation of the security by settling the secure framework, and then after we talk about installing the DBMS and setting up, deploying the project, is just to delimit the attack surface, to just recognize what are the entry points, but they draw what can be the attack surface. So by delimiting the attack surface, the attack surface via it is the way how to eliminate any intrusions that cause intruders to succeed accessing the environment somehow. So the context of to reduce the attack surface is the purpose of recognizing the vulnerable points or the access points. At least we cannot say vulnerable, since we are forced to give remote access to the resources, or just to give an in-out flow to work, yes, to be validated. Those are access points, and those are all of them. Generally, they are the attack surface. Recognizing them and going beyond the authorization and the access control, it whatever the theme we apply from those four themes, we delimit, we reduce the chance of giving intruders success or access. Okay, the transaction mainly, actually, we can settle it up be on top of a secure transaction. Yeah, sorry, a secure framework. Yeah, absolutely. But here we can see an environment, the DBMS, how it has been actually tackled. We see an access device and an access interface via which we use a peripheral, whatever the peripheral is. We have different, let's say, hard equipment via which we can refer to, or a user or an end user can refer to in order to use the resources. Uh, an access control that can be actually awarded to the transaction. Transaction means there is a session, there is a privilege to be awarded the user. A simple query coming from a system, whatever. There is an access, it has to be actually controlled. And we have actually a list of those access controls, a list of functionalities to, yes, either allow or deny, or just specify the session or the permission given, what it draws. So the first security we settled at the beginning, if you remember the unit number 1, when we tackled the APIs, the SSDT, SMS, and the Visual Studio, we said that the physical security is the first security approach to settle on when securing a database. Here we see it again. survey is the first, database are the second, third the schemas, and then after comes, and inside the schemas we can find the objects. So still it's validated, we did not neglect, and we cannot neglect. It is a standardized approach. So all what we saw so far, see now we are coming back. We are at the end of this semester, and we are coming back again to the context of the physical security. So it is the beginning and it is the end. Segregating and physically separating resources from the end users is the first security and the end security. It's not actually, I'm just insisting on that. It's not technically when I said the first and the end, but I'm just insisting on that. Just to bring your attention, to stress on that, to put you on a level to understand that it is important enough to refer to it again and again and again and again. The security actually, in this unit, actually, we are going to tackle a variety of security approaches, but we are not going to tackle all of them for constraints, whether it's the time that we cannot cover or because of our interest. The direction of the book now is showing us the login to the entities inside the database management system, the SQL Server in question. We have two modes, whether we use the system or the environment access, the user authenticated as a Windows user. You are from the framework because the SQL Server is a Windows product, so it can use the Windows authenticated accounts to allow access to the resources, to the databases. Yes, it can be configured for that. This is why, because the product is correlated, no more, no less. So the SQL Server, if you can give actually credentials from a different platform, it won't work. Platform, I mean here the operating system, or the environment, I mean here the operating system, the Windows here. The second one actually is to configure your DBMS, which is also, again, I'm using DBMS, but our DBMS is the SQL Server. So to authenticate the logins, usernames or credentials to be given to different accounts. Second approach, second preview. It's clear. We saw that in the lab, and we explained and we stressed on that more than one time. More than that, the third point is that access to the resources within a database management system, and the database management system here is the SQL Server. See how many times I'm insisting on that. It can be done versus direct database versus specified database. We can say they are technically nominated as contained databases. Contained databases means database, they are available inside the database management system, and towards specific database number 1, database number 2, database number n. For example, we say students database, or colleges database, or we may say hospitals database. Specific database actually can be tackled specifically to be given to Fulani to access that particular database only. For example, the database management system has, for example, 10 databases or 100 databases, list of databases inside. But one particular database, only one or two specific database, in singular I'm talking, to be awarded access or to be allowed to be utilized by specific login. Login here, when I say login, means credential, recognized, mapped user, mapped path. This is a contained database. This is what we technically describe, how we describe the contained database. It allows users to connect to SQL Server by authenticating directly against the database. Against the database, not against the SQL Server. So the SQL Server will allow you, if you have an access specified, and this access, this login is mapped directly to a database, it will allow you to open the specific database only. You will not see anything else. And you cannot do anything on the DBMS level, means to create stored procedures here, CLR stored procedures here. No, only inside. If you can do that, if it would be inside the database itself. So from within the database body, yes, but within the server, no. The alterations we saw when we created transactions, if you remember very well, when you created stored procedures, or when we created these stored procedures, common language runtime, the CLRs, we have two levels, whether we are at the level of the server or at the level of the database. The level of the database when working with the contained databases, yes, or the tasks they can be done. Actually, you can generate a common CLR on the database. Yes, you can create logins and security control on the database. Yes, you have the maps and the let's say the properties of the database under your control. More than that, server side, no. This is the private level. This is a limitation. This is a constraint. Any questions here? Okay, that's great. So no questions, I believe so, since you don't. From this part, immediately we pass to the last paragraph in this chapter, which is the how hackers attack SQL Server. Actually, previews they are numerous on real plane. All the security perspectives we saw, the security techniques, the 5 security techniques we saw on the digital security course, if you remember well, they are questions to be implemented here to avoid attacks on the SQL Server, digital environment. But let's take it from the other side. So we are not implementing security techniques here. We are seeing the weak points in order to recognize how they do. So you are a hacker, you are a cracker, you are willing to make or to send a query to illegally, non-legally, in an illegally way. You want access to the SQL Server. What are the vulnerable points we are going to explore? What are the weak, let's say, access points via which you would like to interfere into the SQL Server or into the contained database or whatever the resource available inside the SQL Server, the DBMS. Weak administration. Here, the first point. What does it mean? In the sense of actually the controls we can set. When we say actually we are having actually a map to a user, for example, user number 1, he's having an access, yes, but he is only able to read or to display. He is mapped to only read data from the means he is able to execute the select queries only from within a given database. Yeah, okay. This is the sort of an administration. Yeah, so we are controlling, we are mapping users to resources. We did that. So in this level here, actions similar to this, we can do actually bad configurations, bad options. We can settle things that they are not finished. We cannot do all the we cannot give all actually the restrictions to a given user, for example. This is a weak system administration. This is an example of a weak system administration. This is a way from which an attacker would start. Don't expect, and especially in today's environment, that hackers or crackers, they are genius enough to decide to say, I am a cracker, so I will break into the system without any need. No. It's not like that. It's not a mystery here. It's not a mystery. Remember what I'm saying clearly. So mistakes, they are access points for whomever is trying, whether to break into the system illegally or for ethical purposes, to check up the security level. Both of them, they are to explore mistakes. When we say weak system administration, the weak here because of the non-awareness or the lack of skills, no more no less. The second point here, actually, the account passwords. Still, we are talking about the weak only, but account passwords, if you're just using, for example, your own account to access the SQL Server, you are using the password 123456. Do you expect that this would be actually a type of a password you may count on? Absolutely no. it would be breaking in few moments, not second, not even a second. The simple brute force, or let's say a dictionary attack, we explained at the early of this. If I remember well, we explained the cybersecurity, and we explained here also, and explained regardless the brute force attack. I would guess it would actually make the hacker fall into what is your password, 1 2 3 4 5 6. This is not a type of a pass. So um, passwords options is one of the considerations that an attacker might think of to guess how to do a brute force or to generate actually dictionary attack, something like that. Other services that an attacker or a hacker, even a cracker, uh, might think of to attack an SQL server is the services delivered over a web browser. Here, actually, we talk about the SQL Server browser. We're given an interface via which an API via which we have access to resources, and those resources they are hosted by an SQL server. So we talk about remote over the web or something like over the network, whatever. We are using a browser, a complete different API to access the resource. Just give me a second, please. So the services to be accessed remotely, actually, they are a disaster actually for any service deliverer. Means any service provider, any owner to deliver a service over the web browser or remotely over the WW specifically, not only. It's a disaster. Why? Because it is hard enough to control. Everything is in a public network. Mainly when we talk about a browser, so we talk about a public access. So this is one of the very common access points that an attacker or a hacker or a cracker may think of to attack an SQL server. Techniques to use to fulfill or to accomplish an injection is another model via which an attacker might think of. Remember the injections we saw. We saw groups of SQL injections in this course only. Without actually going behind the details of the injection, you have to recognize them. You have to recognize what are the injections and the examples of the injections towards the SQL provider, the SQL server. Now, question. Intelligent observations here, they are measures. They are measures that service providers or services providers, they think to utilize their own platforms in order to deliver their services or their resources, give access to their resources. Those intelligent observations, they are, yes, they are, as per the title, intelligent, yes, but they actually provide a lack of maybe standardized security policies, standardized security tools to be utilized, and specifically the filtration or the filters to be utilized. These are as per the description of our book, and it is true. So to count on yourself only to secure your environment, yourself means you're actually talking about the business owner or the service owner. It is not enough. So if you are doing so, hackers or crackers or whomever is the attacker would recognize that you are not using standardized security measures as per the themes we described at the beginning of this unit, and then after he may do his job to start his attack. We are not discussing, actually, as our book is describing that intelligent observations, they are an attack point to an attacker. Why? Because service owners, they are using their own algorithms and security measures to secure the framework. Right away, it is said like that, literally like this. Yes, absolutely, it is intelligent enough, but it is not the top security you may think of to secure the framework on top of which the DBMS in question is running. Thus, it is an attack point via which an attacker or cracker or hacker may start his attack. Any questions, please? Again and again. Let's I'm gonna just discuss the definition of the unit number 5, and I'll stop here at this level. Sorry, 6, which is the relational databases in relation and the correlation with the XML. So the one of the very famous outcomes of a database management system here, actually, to give us an structured outcome. Displayed was as for example, what an XML file can give us in output. So the XML is one of the very example of structured content, let's say, display methods. One of the databases, relation databases that we can count on, like the SQL Server we are using, can generate files and structured, let's say, files based on the XML, and at the same time can give us paths for the XML itself. So can generate and give us an outcome as an XML file or resource, or at the same time can generate and keep it inside, keep it locally in his, let's say, internal storage, and give us actually a path for the XML, whether to generate an XML resource to be utilized and to be exported, utilized by the end user, given to be utilized externally, then externally from the SQL Server in question, or to give us a path for the XML to be utilized from within the body of the from within the DBMS, and then after from within the database in question. This way we terminate the full unit, the full entity, completely finished. Just to give you a few minutes to interact. Otherwise, I'd like to ask you 1, 2, 3, just to make a small recap on the content.